good. All right, so here we go. All right, so we're going to start talking about rational functions, and we'll talk about graphing rational functions. So rational function is just nothing more than a polynomial over a polynomial. Okay. Here we're going to strictly talk about domain. We're going to have another domain question on your quiz this week. I need to write it. I have the quiz mostly written, then I went and tested it, and it gave me, I put in the right answers, which I told it to give, and it didn't say. It drives me nuts, but I will triple check it today. All right, so for domain, we've kind of gone over some of the stuff before, but let me just reiterate it real quick. So here, if I have a square root of x, that means the domain here has to be, it's equal to 0 up to infinity, right? Because x can't take a negative stuff. I know we just went over complex, but for reals, because we're going to go back to real land for a second, the domain's here. A domain for a polynomial is all real numbers, right? So it's everything. Okay. So polynomials, here the domain, I could put anything at all because here there is no x. So for here, I don't want a 0 on the bottom, right? I don't want zeros on the bottom. So here I want x squared minus 5x plus 6 not equal to 0. And this actually is the reason we're going over this. So where is that at? It's x minus 2 and x minus 3. So here we're going to have the domain is all reals except x you can't except equal 2 or 3. Okay, to write it. Here we need to say, so the top part is forcing me to have this. Well, what's the bottom part forcing me? Well, x cannot equal, so 3x plus 2 cannot equal to 0, so x cannot equal negative 2 thirds. But notice this is already thrown away in this, and so it's just, so here we can just safely write this, okay? So x can't be negative 2 thirds, but x had to be positive anyway, so it already was gone, so we can safely write this. Here we want to have x strictly greater, so x plus 2 is strictly greater than 0, because if the square root allows a 0, but being on the bottom, I can't have that, so I have to strictly throw it away. And so here, we just solve the inequality, and here when I do that, I'm going to get x is greater than or equal to 2 thirds. And so here I'll just write that as negative, oops, not including. So remember, parenthesis means not including, the bracket means including, so 2 thirds to infinity. Okay. So that's just a rough thing to look for. The main things we're talking about domain here is the square root has to be from 0 to infinity. If it's on the denominator, it can't be 0. So here we have to throw away these two numbers. So everything but those two. If I wrote it out the other way, it'd look like this: minus infinity to 2, union 2 to 3, union 3 to infinity. Okay. If you write it this way, that's fine. I mean, if you wrote here the domain is all reals, that's fine too. So that's just definition of domain, just stuff to go over. Properties of fractions. So here's all your properties of fractions. When you multiply fractions, you can just multiply across. When you divide fractions, you can flip this one or take its reciprocal, right? And multiply across. When adding or subtracting fractions, you need the same denominator. Also know that this is what allows us to go, when I have this, I do this a lot when we're doing the quadratic equation. When we have something that looks like this, I'm allowed to split it backwards to that. It's what allows me to split it. Now, if I have C over A plus B, I cannot write it as C over A plus C over B. Right? This is something you definitely cannot do. This is bad. Will I see it at some point? Yeah. That's when we're doing it by hand. Actually, I want to actually see you guys do it, but someone might try to do it. So this is bad. Don't do that. It gives you incorrect results. Adding or subtracting things with different denominators. Here, you just basically multiply by D and D, right? Just a really bad joke right there. Just a really bad joke, and I'm not going to tell it. Anyways, and then here we're going to multiply by b and b, so b over b. And so that would give us, the bottom part would be BD, and then we'd have 80 plus C, BC. And so the same thing with that. And then you can cancel common factors. And so if it's common everywhere, you can do that. Another thing that is often I see with this is you cannot do this. This is bad as well. Don't do this. So it has to be a factor, not a term. You can cancel terms, you can cancel factors. So those are a brief overview of all your factor rules. And so here we're going to be doing this as we want to simplify rational expressions by canceling. So here if I have x plus 1 and we divide it by, here I can factor this as x plus 1 and x minus 1. And then here I can cancel this out and I get 1 over x minus 1. Okay. So those are just, and so here we can simplify the rational and get it to that point. Here, x squared plus, so that simplifies into x plus 1, x minus 1. I assume you know how to do difference of squares because this is technically 1 squared. And so if you have a difference of squares, you just, it's x plus the square root and x minus square root. And then here on the bottom, if I factor this, I get x minus 2. No, x plus 2, sorry, plus 2. X minus 1. Does that add up right? Yep, okay. And here I can cancel the x minus 1, since I'm left with x plus 1 over x plus 2. Okay. And so that's just ways of simplifying rational expressions. And so here you just factor these into its terms, and then you cancel what's the same. All right. All right, so now we're going to do rational expressions by multiplying and dividing. And so here we're just doing a lot of 1.4 is just nothing but a lot of algebra to get you used to messing with it. All right, so in order to do this, the best thing we want to do is factor this completely, absolutely as best we can. So here, x squared plus 2x minus 3, this factors into x plus 3, x minus 1. I'll go ahead and multiply that. So for multiplying it, we can just pretend this bar goes all the way across and then do this. And so here I can pull out the 3 and then I'll have x plus 4. Right. Let me just stop real quick because I have been going into the clip. Is everyone okay how I got this from the top? Here we're just factoring a lot of quadratics. Yes. All right, everyone's good. All right. I was like, well, if they don't understand what I'm doing for this, I might be just blasting through it and they'll be getting lost. All right, so from here, what is that? That's x plus 4 and x plus 4, and then x minus 1. All right, what can I cancel here? I can cancel an x plus 4, x minus 1. So I have 3 x plus 3 over x plus 4. Okay. For this one, in order to simplify it, we're just going to multiply by the reciprocal. So the bottom's going to come up. So this here on the bottom, because I'm dividing, will flip. So 5x plus 6. And then on the bottom will be x squared minus 4 of x squared minus 3x minus 4. So all I did is flip this and multiply. Now we're going to factor, so x minus 4, this will be x plus 2, x plus 5, so here I want 6, adds up to 5. Oops, why? Here I want 6, adds up to 5, my brain, this is why I have to be very careful, because I want to explain what I'm doing while still writing it down, and so my brain will write what I'm thinking, not what I'm trying to do the math. So here, add multiplies to 6, adds up to 5. Here we have difference of squares, so the x minus the square root of 4, so it'd be 2. X plus the square root of 4, which is 2. And then here, I'll have x minus 4, x plus 1, because I want to multiply -4, add up to -3. All right, so what can we cancel here? We have a -4 on top and bottom. We have an x plus 2 on top and bottom, and that's it. So we have an x plus 3 all over x minus 2, x plus 1. Okay. And so that simplifies. Now, if we have to add or subtract rational functions, we need to make them look the same. And so in order to do that, here we're going to have, here I need to have a common denominator. So the smallest common denominator I can get right here is x minus 1 times x minus 2. So this is what I want on the denominator, is x minus 1, x plus 2. And so in order to do that, I'm going to multiply x minus 1 over x minus 1 on this side, and then x plus 2 over x plus 2 on this side. So I'll have 3x plus 2 plus x times x minus 1. Okay, because if I multiply top and bottom by the same, it's multiplying by 1. And so I guess we need the common, so this gives me 3 times x plus 2, and then here I'm by top and bottom, so give me x plus 2, x minus 1. It'll be x times x plus 1. And then from there, we can just kind of simplify it a little bit. So we'll have 3x plus 6 plus x squared minus x all over x minus 1, x plus 2. All right, so that gives me x squared plus 2x plus 6 all over x minus 1, x plus 2. And I don't think I can factor that anymore. No. So this is as close as you can get it. Here, we're going to do this again, but notice here that if I have a difference of squares, here I'll have an x, it'll be x minus 1, x plus 1, minus 2 over x plus 1, x plus 1. So I really don't have to multiply by everything. This just needs another x. Here I have x minus 1, x plus 1. Here I have x plus 1, x plus 1. The closest thing I can do would be x minus 1, x plus 1, x plus 1. And so here I need to add an x plus 1. So you actually don't have to do the entire thing. You can just do what would get you a common denominator. And then here I'll need to do an x minus 1. 3x minus 1. So if I did all that, I'll have 1 times x plus 1 minus 2 times x minus 1 all over x plus 1 squared, x minus 1. And then if I just clean that up, that will give me, I'll just do this real quick. So let's say negative. So this is just x plus 1. This becomes plus 2. If I factor that in, so I'll have minus x plus 3 over x plus 1 squared over x minus 1. Okay. And so this is just working with rational functions. You'll mess with it a little bit. You'll get more comfortable with it. All right. We'll just talk about two things real quick, and then we'll get on to the section that we should probably spend more time on. All right. All right. So here, sometimes we want to remove compound fraction. Compound fraction is fraction within a fraction. And so in order to do this, let me show you the process slowly. So here, let's make this a single fraction. So let's make top and bottom a single fraction. So here I'll have x over y plus 1. But in order to add those two together, I need to have a common denominator. So I'm going to multiply by y over y. And then here I'll have 1 minus y minus x. And so in order to make this a common denominator, I'm going to multiply by x over x, because this is technically 1 over 1. You can always put something over 1. All right, so that will give me, I didn't leave myself very much room. That will give me x plus y over y divided by x minus y over x. Because this gives me x plus y over y divided by x minus y over x. And in order to do this, we just flip and multiply. So the next step here, draw a little line, x plus y over y times, so here I'm dividing, it would be x minus y. And so if I simplify this out, I get x plus y over y, x minus y. And so here I've gotten rid of the compound fraction. So what you do here is you make this a single fraction, and then flip and multiply. We'll do the same thing here. So here, we're already good. So here we just need to make the top part a single fraction. So here I'll have 1 over a plus h minus 1 over a all over h. And so here I'm going to have to multiply by a plus h over a plus h. Here I have to multiply by a over a. So I'll get a minus a plus h all over a times a plus h divided by h. And then here we just multiply, so we just kind of flipping it over. So I'll have a minus a plus, hold on, let me simplify this real quick. No, it's fine. I'll just do it in 2 steps. So I'll have a minus h over a plus a h. And then here as I flip it, this will be h over 1. These a's of course cancel. And so that leaves me with, oh, hold on. If I flip this, I didn't flip it. If I flip h, what do I get? I should get 1 over h. And so what do I have here? I have minus h up top over a plus h times a. 1 over h. Here I can safely cancel the h's, so I'm left with 1 over a times a plus h. And then, oops, my negative. Okay. So here, technically this is h over 1, this is h over 1. So when I flip it, it becomes 1 over h. I just cross multiply. Yeah, cross multiplying works fine. If you write it as, you could rewrite this as a minus h over a, and then divided by h, and you could cross multiply, and that'd be fine too. That's another way of doing this. Is this going to be on the quiz? I think I give you a simple one, something kind of close like this to do. So if you want more practice tomorrow, we can crunch through something. Basically, combine the fractions and then flip it. It's just you're gonna need the skills of manipulating or moving around variables in calculus, and so it's important to do this. The process here is the same. Combine the fractions. So put the fractions together, and so you have a fraction over a fraction. So here we did that, we put them together. So in order to do that, we made this y over y and x over x. And so we got this as a fraction over a fraction, flip and multiply. And that's all you need to do. Here, same thing. We have the fraction of h over 1. And so we put these two fractions together. So I have a fraction over a fraction. Then I just flip and multiply. Oh, someone got kicked out. I need to put them back in. Boop. Okay. Yeah, so you just combine the fraction, flip and multiply. All right. So let me just, we need to do more practice on this. We can do this at the end of the day. I just want to make sure we get through everything that we need to get through. All right, so the last one is conjugate radicals. We did conjugate we did conjugate complex conjugates. You can do the same thing with radicals, get rid of radicals. So if I want to get rid of the radical here on the bottom, I can multiply by 1 minus the square root of 2, 1 minus the square root of 2, because then this becomes the difference of squares. And so I get 1 minus the square root of 2 on top, and then I get 1 times 1, which gives me 1. I get 1 times plus 1 plus square root of 2, 1 minus square root of 2, which of course gives me 0. Then I have square root of 2 times square root of 2, so that's plus the square root of 2 squared, which is just 2. And so, no, I have minus the square root of 2. Hold on. Minus the square root of 2 squared, which is 2, which gives me 1 minus square root of 2 over negative 1, which is just 1, negative 1 plus square root of 2. You almost never do this, so you know what, just skip this for now. Just skip, don't care. Legit don't care on this one.